Assalamualaikum warahmatullahi wabarakatuh. My name is Umi Islam Ismail. I am from SMN 3023 Group B. So, my question that I'm going to explain is evaluate the limits of x approaching 0, 1 over sin x plus 1 over x squared. So, first of all, what we need to do is, we got the question limits x approaching 0, 1 over sin x plus 1 over x squared. We have to equate the denominator to get a single fraction. So after we equate the denominator, we have a limits x approaching 0 of x squared minus sin x over x squared sin x. And after that, we apply L'Hopital rules. We got limits x approaching 0 to x minus cos x divided by x squared cos x plus 2x sin x. And then we'll substitute the 0 into x, which will result to this equation. This is up to this equation, and then we got negative 1 over 0, which resulting to negative infinity. So from this equation we know that limit of x approaching 0, 1 over sin x plus 1 over x squared resulting to negative infinity. That's all from me. Thank you.
Assalamualaikum, my name is Nur Hazira Midi Daud, code B20, matrix number D201810829887. So today I would like to present question number 2, where there are two equations here, and A is stand for constant of proportionality, G is gravitational constant, and when the object is at rest, the velocity is equal to 0. This question asks us to determine the velocity of the object after a very long period. Okay, next we proceed to this one, where I want to prove this equation into this equation. There are 3 steps, which is the first step is where we need to rearrange this equation into this equation, and Px is equal to E over M and Qx is equal to G. Okay, for next step, by using integrating factor IF, and from this formula we need to sub Px that we find just now, E over M, into this equation. We need to integrate it and we will get exponent to the power of AT over M. Okay, next for third step, multiply equation by IF that we get just now. We need to multiply each one of them from an equation, and by using product rule we will get this one. And after that we need to integrate this exponent to the power of AT over M, where G is constant. We need to let it, we don't have to do anything about it. We need to integrate this one, we will get M over A. And then we need to rearrange this equation by divide by exponent to the power of A over M, and we simplify this equation, we will get this equation where C is constant. Okay, from the equation, it's stated that when the object is at rest, the velocity is equal to 0. So we need to sub this value into this equation to find this constant, and then we will get C equal to negative mg over E. Okay, after that, we need to sub this equation. We sub this equation, and then we need to take out mg over A to simplify the equation. We will get this one. Experiment. Okay, actually from the equation, we can see there's difference between this equation, where there are k, constant A, and constant k, which is actually it's same. A is equal to k or k is equal to A. Okay, next we proceed to the real equation, whereas it's asks us to determine the velocity after a very long period. We know that a very long period is stand for infinity, so we use limit to approach infinity, mg over A, and this we need to take this constant mg over A outside, and then we need to solve this inside, As we know, this is not single fraction yet, so we need to multiply to get the same denominator, and we will get this one. We sub t is equal to infinity, we will get infinity over infinity, which is this one is indeterminate form. So we need, or we should apply L'Hospital rule. Okay, when we use this one L'Hospital rule, we need to differentiate again, and we need to simplify this equation. We will get 1. And finally, we sub into this equation, which is this equation equal to 1. mg over a times by 1, we will get mg over a. Hence, the velocity after a very long period is mg over a. That's all from me. Thank you.
Hello guys, I am Nurul Ain binti Juara, metric number D201-810-82957 and code D9. For this part, we will solve question number 3 that involving the discontinuous integral. Given fx equal to ln modulus x over square root x, find integrate fx dx. Hence, evaluate the improper integral from 0 to 1 of fx dx. To use the partial integration formula, expand the expression into ln x times 1 over square root x. Prepare for integration by parts by defining u and dv, calculate the differential, and determine v by evaluating the integral. Substitute u, v, du, and dv into the formula of integration by parts. Use property of integral where a constant factor can be moved across the integral sign. Reduce expression with square root x, so we will get 1 over square root x. Solve the equation and we will get ln modulus x times 2 square root x minus 2 times 2 square root x. Then simplify the answer and we will get 2 square root x times ln modulus x minus 2. Second, we will evaluate the improper integrals from 0 to 1 of fx. Limit when k approaches to 0. Evaluate the improper integrals from 0 to 1 of ln modulus x over square root x dx. Using the answer from integration of fx, substitute 1 and k into x, so we will get negative 4 minus 2 square root k times ln modulus k minus 2. The answer for the improper integrals from 0 to 1 of ln modulus x over square root x dx equal to negative 4. That's all from me. Thank you.
Question number 4. Determine how large the number p has to be so that integral from p to positive infinity of function 1 over x squared plus 1 dx is less than 1 over 1000. To solve this, the first step is, based on equation from question, we must let t is approaching to positive infinity. After that, we will get the new equation. The new equation will be lim t approaching to positive infinity integral from p to t of function 1 over x squared plus 1 dx is less than 1 over 1000. We must solve left hand side first, which is lim t approaching to positive infinity integral from p to t of function 1 over x squared plus 1 dx. And we must ignore right hand side, which is 1 over 1000. From left hand side, we must integrate this expression. To make it easier, we must ignore the limit first, and the expression will be integral of function 1 over x squared plus 1 dx. By using integration substitution, we put u is equal to x and then du is equal to dx, and then we substitute it into the expression and we will get integral of function du over u squared plus 1, and we integrate it and we will get arctangent u plus c. Next, we substitute u with x and we will get arctangent x plus c, and then rewrite the expression. After we integrate it, our new expression is lim with t approaching to positive infinity arctangent x evaluate p to t. After that, we put value of t and p into s, and the expression will be lim with t approaching to positive infinity arctangent t minus arctangent p. We know that t is approaching to positive infinity, so substitute infinity with t and we will get arctangent positive infinity minus arctangent p. Now we are going to solve both sides. Arctangent positive infinity minus arctangent p is less than 1 over 1000. Pi over 2 minus arctangent p is less than 1 over 1000. Next, we move pi over 2 to the right side. We will get negative arctangent p is less than negative 1.5698. To remove negative, we multiply both sides with negative. And next, we will move arctangent to the right side and we will get p is more than tangent 1.5698. And the final answer is p is more than 1003.69.